Hello guys, we have implemented the hierarchy of employees. Employee class we have implemented and wage employee class we have implemented. So employees having ID, name, salary, and wage employees having hours and rate. The corresponding definitions of the member functions are inside employee.cpp and wage employee.cpp. In main.cpp, I will create the objects of both the classes. Say I have one object for employee class, employee E1 with some values, and I have another object for wage employee class, which is WE1. Now if I display both the objects, then let me compile employee.cpp, wage employee.cpp, and main.cpp. -o emp is the executable that I want to create. So it will get compiled, and if I say /emp, this will display both the objects correctly. First is employee object, 1 abc 10,000 is employee object, and next 5 values 12 test 12,000 10 1,000 is the wage employee object. So this is fine. Up till this it is working. Now let me understand few more concepts like upcasting and downcasting. So suppose I have two different objects of employee class and wage employee class. Now can I assign wage employee object to employee object? Can I say something like this: E1 equals to WE1? So if I do so, and if I try to compile, so yes, it is getting compiled. That means this is valid statement. I can assign derived class object to base class object. Wage employee is a derived class object which I am assigning to the employee object. So that is valid. So in inheritance I can assign derived class object to base class object. That is okay. Now let me try it in other way. Can I say WE1 equals to E1? So now if I try to compile the code, then this is throwing an error. It is not possible directly. You have to overload equal to operator, which is the option, but directly it is built-in support is not there. You cannot assign the base class object to derived class object in C++. Now this is because you say that every wage employee is an employee, but every employee is not a wage employee, right? So wage employee object can be assigned to employee object. Every wage employee is an employee, but you cannot assign employee object to wage employee object, though the size of wage employee is bigger than size of employee. So this is regarding object. Now when this assignment happens, now I told you that size of employee is smaller than wage employee size. So when I say E1 equals to WE1, the extra attributes, size of employee is 28, size of wage employee is 36 bytes. So I am assigning 36 bytes to 28 bytes. So when I assign wage employee object to employee object, the extra attributes which are inside the wage employee object are removed from the object, and that thing is called as object slicing. So here I will write down the definition of object slicing. When derived class object is assigned to base class object, then extra attributes from derived class object are removed from the object, and this thing is called as object slicing. It is sliced out. So this is the definition of object slicing. Now along with employee object and wage employee object, I will declare two more things here. Suppose I declare one pointer which is employee pointer EPTR, and I declare another pointer which is wage employee pointer WEPTR. So now what is possible and what is not possible? Which pointer can hold the address of which object? First of all, let me write something like this: EPTR equals to ampersand even. EPTR equals to ampersand even. So if I compile this, it is getting compiled because obviously this is possible. EPTR is employee pointer and even is employee object. So any pointer can hold address of its own type. That is okay. Now if I say EPTR equals to WE1, whether it is possible, employee pointer is there and it is trying to hold the address of wage employee object. Now if I compile this, this is also getting compiled. That means wage employee pointer can hold the address of wage employee object. Now if I make here WEPTR, then again this will get compiled because both are of same type. And here if I say WEPTR equals to ampersand even, that means wage employee pointer is holding the address of employee object. Now if I try to compile, this will throw an error. That means derived class pointer cannot hold the address of base class object. So I can say that base class pointer can hold the address of derived class object, but derived class pointer cannot hold the address of base class object. That means only upcasting is supported in C++. Now when a base class pointer holds the address of derived class object, it is called as upcasting, and when derived class pointer holds the address of base class object, it is called as downcasting. And C++ supports upcasting by default. So in C++, I will mention it like this: in C++, base class pointer can hold the address of derived class object, but derived class pointer cannot hold the address of base class object. That is, only upcasting is supported. So these are the things that you need to remember when you come across inheritance. So thanks for watching the video. Please do subscribe to my channel. I will see you again in the next video.